I'm hearing a lot of exasperation from C-suites that Kubernetes on Metal pilots for virtualization and AI are taking way too long. And even stronger language from operation teams trying to turn these pilots into production deployments. These companies have experienced cloud-native engineers who know Kubernetes inside and out, but they're struggling. It's because cloud-native infrastructure assumptions don't translate to bare metal. The operational patterns that work brilliantly for VMs and cloud fail on bare metal. Here are 6 ways that physical infrastructure trips up your platform teams. 1. Physical machines aren't fungible. VMs are interchangeable, and it's easy to attach storage or networking. But that's not true on bare metal. That GPU server in Rack 3 has different network paths, cabling, firmware, and performance than its twin in Rack 7. You can't treat them as identical units. Number 2, network topology is fixed. While cloud gives you software-defined networking, bare metal requires you to know where NICs are routed. Configuring nodes for your AI cluster means defining interfaces, configuring top-of-rack switches, managing your actual topology. Physical placement matters with VM storage and low-latency AI interconnects. Number 3, spare capacity economics are brutal. You don't pay for reserve capacity in the cloud, but keeping a $250,000 GPU server idle in a pool, that's burning real money every hour. Bare metal ROI means keeping systems in working clusters. Number 4, every machine has identity and lifecycle. Cloud nodes are supposed to be disposable. You just roll them constantly and don't even track individuals. But bare metal servers are tracked assets with BIOS configs, firmware versions, patch histories, and network configurations. While we can create cloud-like immutable processes and rack scale updates, you still have to manage them as individual units. Number 5, security requires different architecture. Cloud security is mostly applying policy via an API, but bare metal adds whole layers of control. Split control planes for out-of-band management, secure boot configurations, OS-level patching, firmware management across heterogeneous hardware. You need separate security domains for infrastructure access versus workload access. Most cloud-native teams aren't prepared for this. Number 6, operational complexity is real. Kubernetes on VMs assumes a reasonably uniform infrastructure, and bare metal destroys that assumption. You are managing hardware heterogeneity, physical constraints, and complex lifecycle operations simultaneously. When possible, teams should avoid that. But this overhead is justified for workloads that need to run on bare metal, like AI or virtualization. After 25 years of automating infrastructure, I can see a clear pattern. Successful teams use bare metal for workloads that require physical hardware and keep everything else virtualized. VM hosts, GPUs, edge processing, and specialized needs, that's bare metal. Standardized microservices and dev environments, those are virtualized. If you are part of a growing contingent of teams building on Kubernetes bare metal, then talk to us at RackN. We are specialists in making bare metal fit into cloud-native patterns. In fact, a big part of how we've designed Digital Rebar is for that use case. Let us help you meet another bare metal success story.